Welcome back to my channel Shubhangi Insights. So for today we will be doing the topic of dispersion. In the previous video we had done what is central tendency and what are the different measures of central tendency. This is nothing but the second topic, which is dispersion, and along with this we will be learning what are the measures of dispersion. So first let us look at why do we need to do dispersion, what are the reasons for that. Okay. So let us see the three series. In the first series the mean is 10, in the second series again the mean is 10, and even in the third series the mean is 10. Now what is similar in all the three series is the size, which is denoted by n, and the mean x bar, right? In all the three cases you have 10 numbers and the mean is also 10. What is different is the numbers or the given observations. Okay, the data available in all the three series. In the first series the data given to us are all 10, 10, 10 and 10. In the second series the data is 6, 7, 8, 9 and so on. In the third one it is 2, 3, 5 and so on. Now when we have to compare the central value for this, the central value is 10, but we need to see how much is the other values in the given observation varying from this central value. In the first case, if we see, the mean is 10 and the difference between all the observation is 0. The difference is 0. That means the data, the mean given into the data is 10 and the observations are also 10, so there is no difference between the mean and the set of observations given to us. Let us come to the series number 2. In this the mean is 10. Now how much is it deviating from the given observation? In the first it is 4, 3, 2, 1, 0, 1, 2, 3, 4. So the difference is either increasing or decreasing in this case. The numbers given to us in the data are slightly fluctuating from the central value. Now let us go back to the series number 3. In this case the difference here is 8, 7, 5, 3, 0, 3, 5, 4, 6 and 9. Here also we can see there is a difference from the observations to your central value. So from this what do we understand? That even though if your size of the data and the mean of the data are same, but the nature of the data needs to be seen so that we understand how much are the values deviating from that particular central value. In order to study this, we do the topic called dispersion. So what does dispersion actually means? The study of scatter or variation of the values in a data from any measure of central tendency is called as dispersion. So how much is the data or the value deviating from this particular central value? That is what we are going to see in this topic of dispersion. Now let us see what are the different measures of dispersion. Like in the previous topics we had seen what are the different measures of central tendency, like we had mean, median and mode. Similarly in this also we will have two main topics, absolute measures and relative measures. Before getting into what are the different absolute and relative measures, let us understand what each topic means. Now, absolute measures are those which has units attached to them. Now, what do you mean by units? It might be centimeter, meter, kilogram and so on. If a value is given to you, you attach that particular unit along with that. Now, when we talk about relative measures, in this case there are no units attached along with your answer. Why does it happen? Now for example, relative measure is something which is denoted in the form of numerator by denominator. You will see that all the formulas in relative measures will have numerator by denominator in fractional form. Where something is in fractional form, the units will be attached along with that, right? Now when you divide those units by numerator and denominator, it gets cancelled away. So in this case you will not have any units attached. That's the reason we tell that relative measures will not have any units in that particular answer. Now let us look at what are the different measures under each topic. Under absolute measures, the first one is your range, second is your quartile deviation, third is mean deviation, and the fourth is standard deviation. Similarly, in case of relative measures, you will be learning coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, and in the last, coefficient of standard deviation. You can also call this as variation, coefficient of variation. Variation denoted as CV. Okay. So these are the different measures which we will be learning under the dispersion. The first measure of dispersion, which is nothing but range. Now what do we do exactly in range? The difference between the highest value and the least value in the given data. Now for example, a set of data is given to you. First step is to find out the highest value in the data and then find out the least value. After finding out those values, you are supposed to subtract the highest from the lowest. You will get the value of range. Now why do we do this? In order to get the idea that how many values are exactly there in your particular set of observation. Now when you have to find coefficient of range, as I told you, it is a relative measure, so obviously it will be in the form of numerator by denominator. So what are we going to do here? Here we will take highest minus lowest and we will divide it by highest plus lowest. Basically whatever you had in your numerator, you are going to have same thing in your denominator, only the changes your sign. Here in numerator it was minus and in the denominator it has just become plus. So this is the way you can remember the formula. Let us have a look on the problems based on the range. Let us consider the first question. Find the range and its coefficient for the following data. These are the set of observations: 23, 53, 81, 52, 47, 61 and 55. So what are we exactly going to do here? What is the formula for range? First you write down that range is equal to highest minus lowest. So in this case we need to find out the highest value from the set of observation and the lowest value or the least value. Now in this case our highest value is 81 and the least value is 23. So we are simply going to substitute that 81 minus 23, which is 58. So this will be your answer for the range. Now they have also asked us to find the coefficient of range. So we will be writing coefficient of range formula first, which is highest minus lowest divided by highest plus lowest. So the values are 81 minus 23 divided by 81 plus 23, which is 58 and the answer. Okay, so this is the answer for coefficient of range. So this is how you need to understand the question first. What are they asking you? In this case, they asked you only range and coefficient of range. So you will simply apply that particular formula, substitute the values and get your answer. It's very good that you even mentioned the conclusion part, that the range for the following data is this and the coefficient of range for the data is this. It will give a proper ending to that particular question. Let us look at the second question. If the least value and the highest value in the data are minus 8 and 60, find the range and its coefficient. In this particular question, they have directly given us what is the highest value, what is the lowest value, and from that they are asking us to find the range as well as coefficient of range. So you can simply write the formula for range, which is highest minus lowest. Now read the question well and then substitute the values. If the least value and the highest value, so the first value which they have given to you is the least value. So your least value will be minus 8 and your highest value will be 60. So 60 minus of 8, which is 60 plus 8, and the answer is 68. So this is nothing but your range. Now let us go to the next thing, which is coefficient of range. Now coefficient of range formula is highest minus lowest divided by highest plus lowest, which is 60 minus of minus 8 divided by 60 plus minus 8, which is 68 by 52. So the answer for this will be 1.307. So this is your answer for your coefficient of range. Now you can use your calculators. If your college allows to use scientific calculator, go for scientific calculator. Otherwise a normal calculator will do your stuff and you will get your answers. So don't forget to carry a calculator while going for exams, and make a practice of doing it when you are practicing the questions. It will make your calculations really faster. Okay, so in this case you have found again your range and coefficient of range. This question gave you the details directly, you just needed to substitute it. Look at the next measure of dispersion, which is nothing but quartile deviation. Now what is quartile deviation? QD is defined as half of an interquartile range. Now half of interquartile range, what is the range here? Interquartile range means Q3 minus Q1. If they simply tell you find out interquartile range, you will just take the highest minus lowest, again in form of quartiles. In range, we will be taking directly highest value and the lowest value. In case of quartiles also, we have something called highest and lowest. So that's what we are going to take in case of interquartile range, Q3 minus Q1. But when they talk about quartile deviation, you need to divide this interquartile range by 2. Similarly, the coefficient of quartile deviation will be again taken in the form of fraction, Q3 minus Q1 divided by Q3 plus Q1. Again, whatever is there in the numerator, you are going to take same thing in the denominator, only the sign changes. This is the difference you will see in your absolute and relative measure for all the formula. Let us look at the question based on quartile deviation. Now what are they given us in the question? If Q1 is 36, Q3 is 64, find QD and its coefficient. Now we know the formula for QD, which is nothing but Q3 minus Q1 upon 2. Already the values are given to us for Q1 and Q3. We can directly substitute those values, which is nothing but 64 minus 36 upon 2, 14 after substituting. Okay, this is the value for quartile deviation. Let us see what are we going to get for coefficient of quartile deviation. First, write down the formula, which is Q3 minus Q1 upon Q3 plus Q1, which is 64 minus 36 divided by 64 plus 36, 100, and answer is 0.28. So these are the answers for quartile deviation and coefficient of quartile deviation. It's very simple. If the data is given to you, you just directly need to write the formula and substitute the values. Look at the second question. If QD is 17, Q1 is 22, we need to find Q3. So obviously in the data they have given us QD. So we are supposed to consider the formula for QD, which is Q3 minus Q1 by 2. Now what are the values given to us in the question? Value of QD first. So we will substitute that in place of QD is equal to Q3. Q3 is not given to us, which we are supposed to find Q3, and Q1 is given, which is 22 divided by 2. Now what we will do, we will simply cross multiply. 17 to 2, 34 is equal to Q3 minus 22. Now we need to find out the value of Q3. So it's better to keep the unknown value on your left side and set rest of the values to the right side in order to calculate. So what I'm going to do, I'm just interchanging these values. I'm bringing the right side to the left and left to the right and substituting this, because we need to find the value of Q3. Now Q3 is on my left side. We will send all the rest of the values to the right. So it will be 34 plus 22, and the answer is 656. This is what was asked. Find the value of Q3, and we have got the value. Okay, let us look at the next question. Calculate QD and its coefficient for the following data. This is a set of data given to us. We have to find QD and its coefficient. So let us write down the formula for that. QD is equal to Q3 minus Q1 by 2. So we need to first find Q3, we need to find Q1, and then substitute back into this formula. In order to get Q1 and Q3, first let us write down the formula for Q1 and Q3 based on your raw data. Now the data given to us is raw data, raw or ungrouped data. Now we have already seen the previous videos. When a single series of data is given, what is the formula for Q? When discrete data is given, what is the formula for Q? And when continuous data is given, what is the formula? Now here, based on your raw data, Q1 will be I into small n plus 1 by 4 observation, right? So here small n is nothing but your number of observations given in the data. I will be whichever quartile you are substituting for. We are substituting the first quartile. So value of I is going to be 1. So now let us substitute. I is 1. Your n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 digits are given plus 1 by 4 observation, which is 13 by 4. And the value of this is 3.25. 3.25 observation. Now, how are we going to get this particular value in our data? See here, one more thing what we need to see is your data. Here your data was already arranged in an order, maybe ascending or descending. If your data is not arranged, in case of raw data, you need to first arrange your data and then find out that particular value in your data. Now, the value given to us is 3.25. Now, it will be between your third value and your fourth value. Now, we don't know exactly where it is going to be. So, what we have to do, we have to open up this particular number. So, how are we going to do this? There is a way or a formula which you have to apply while solving this type of values which you are going to get. Now, for 3, you are going to consider it as third observation. Wherever your decimal starts, you will apply a plus mark. Whatever is after the decimal, you will write it as it is, 0.25. You will open the bracket. The next observation after your third observation is fourth observation. You will subtract that fourth minus again your previous observation. And this is how you are going to get your answer for this 3.25th observation for your entire data. Now, which is the third observation? Third is 80. You will be substituting 80 plus again 0.25. Your fourth observation is 82. So 82 minus third is again 80. And the final answer for this will be 80.5. So this is the value for Q1. We will be substituting this value of Q1 in our data. We will write it as inside Q1 is equal to 80.5. Similarly, we will be finding the value of Q3 by again substituting in the formula. So here, for finding out your Q3, what are we going to do? We will be multiplying this with 3, 12 plus 1 by 4 observation. So the answer for this will be 9.75th observation. Again, what are we going to do? We are going to again open up this particular value, which will be 9th observation. The first value will become your observation plus. After your decimal, you will be writing same with a plus. Then after 9, you have 10. So 10th observation minus 9th observation. Now, what is the 9th observation? 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 86. So 86 plus 0.75. Your 10th observation is 88. 88 minus 86. And your final answer is 87.5. So this is the value of Q3. We will simply write it down here. Q3 is equal to 87.5. Now, we can substitute these two values in the formula, which is 87.5 minus 80.5 upon 2, and the answer is 7 upon 2, which is 3.5. So this is the answer for your quartile deviation. Now let us find out the coefficient also, because that is also asked us in the question. So the coefficient for quartile deviation is equal to Q3 minus Q1 by Q3 plus Q1. It is a very good practice to always mention down the formulas and then do the substitution, because everything carries the marks, and second, you get to learn the formulas again fast when you keep practicing them for each and every question. Okay, now the values are 87.5 minus 80.5 divided by 87.5 plus 80.5. So the answer for this is 7 upon 168, which is equal to 0.042. So these are the answers which you will get when you have to yourself find out value of Q1, value of Q3, and then substitute back in the formula. Let's look at the next question. Calculate semi-interquartile range and its relative measure for the following data. So we have ages given to us, number of persons given to us, and they are asking us to find semi-interquartile range. As we have already seen the formula, interquartile range is nothing but Q3 minus Q1. Since they have added semi means half, right? So you need to take quartile deviation formula, Q3 minus Q1 by 2. Okay, so we will be writing down the formula. Quartile deviation is equal to Q3 minus Q1 by 4. This is nothing but your semi-interquartile range. Now for that, first we have to find out Q1, then we have to find out Q3, and then substitute back into the formula. So Q1. Now first we need to understand which data is given to us in order to calculate our Q1 and Q3. Since we have ages X value given to us and we have number of person frequency given to us, if X is attached along with F, this is called as discrete data. Now what is the formula for discrete data? It is nothing but I into capital N plus 1 by 4 observation. Now what is your capital N? Capital N is nothing but sum of frequency. So first we need to calculate the total of frequency, which is nothing but 543. Now we will substitute in the formula. Since we have to find first quartile, I value will be 1. 543 plus 1 by 4th observation, which is nothing but 544 by 4th, 36th observation. Now where do we need to search this 136? In our LCF column. Since see, here we have data given to us in unorganized manner, correct? Frequency first it's increasing, then it's decreasing. So we cannot search this particular number in your frequency column. We have to calculate LCF, or least cumulative frequency column. From that we will be finding out where does this observation lie. So how to calculate this, we have already seen in the chapter 1. You can go back and see that video again. So first value will be as it is 3. Next you need to keep on adding your first value with the next value. 3 plus 61, 64. 64 plus 132, 6. 9, 196. Next again 9, 349. Again 9, 8, 489. 540, and again in here you're going to get 543. So these are your values which we got in LCR. Now let us search where does this 136 value lie. You have to search in LCR column. Now 136 is lying between 64 and 196, but we need to consider the highest value. So 196 row will be considered as your Q1 column. Okay, will be considered as your Q1 column. So the value of Q1 will become 40 from this particular case. This value becomes your Q1 value. Now once you have got your Q1, now we have to find again your Q3 value. Q3 will be nothing but 3 into capital N plus 1 by 4 observation. So which is 3 into 544 by 4. 544 by 4 observation, and your answer for this is 408 observation. 408 observation. Let us search this 408 in your LCF column. So where does it lie? it lies between 349 and 489. So we will consider the highest, which is this. So this will become your Q3 column, and the value of Q3 will be your 60. So Q3 is equal to 60. So we have got your Q1 and Q3. Now we will substitute back in your QD formula in order to get a semi-interquartile range value. Let's substitute back and see what answer are we getting. Q3 is 60, Q1 is 40 upon 2, which is 20 by 2, and your answer is 10. This is the value of quartile deviation. They are also mentioning and find out the relative measure. What do you mean by relative? Coefficient of range, right? Coefficient of quartile deviation. So let us find out that also. Coefficient of quartile deviation is nothing but Q3 minus Q1 by Q3 plus Q1. So after substituting, 60 minus 40 divided by 60 plus 40, which is equal to 20 by 100. And answer is 0.2. So this is the value we will get for this particular question. So you have to basically understand which kind of data is given to us in order to apply the appropriate formula. Let us look at the next question. Calculate coefficient of quartile deviation for the following data. So they have directly told to find out coefficient of quartile deviation. Now even for finding out coefficient of quartile deviation, we need again Q3 and your Q1. So let's write in the formula first. Coefficient of quartile deviation is nothing but Q3 minus Q1 by Q3 plus Q1. So for that, we need to find out Q1. Now your Q1 and Q3 again will be based on your data. Now we have wages given to us, which is X. We have number of workers given to us, which is your frequency. But this X is in the form of class interval. When class interval is attached with your frequency, it is called as continuous data. When your data is continuous, what formula applies for Q1? It is L plus I into N by 4 minus CF by F into H, right? So we have to get all these values in order to calculate your Q1. Now in order to get all these values, how do we know that which lower limit to take, which CF to be taken, which frequency to be taken, and what is the width size? In order to get all these things, first step is to calculate your I into N by 4. Since you are calculating for the first quartile, it will be 1, and your capital N, as I already told you, is nothing but sum of frequency. So first you need to take the total frequency, which is nothing but 88. So I'll multiply 88 and divide it by 4. So your answer is 22. Now what you need to do, you need to search this 22 observation in your LCF column again. So for that, again we need to calculate your LCF column like how we did it in the previous question for your discrete data. So again the first value will remain the same. Next you keep on adding them. 36, 46, then it is 60, 72, 80 and 88. Now the value is 22nd. Obviously it lies between 12 and 30, but we need to consider the highest one. So we will take this particular row as your Q1 column and your Q and get all the values for in order to substitute. Now what is the lower limit in this case? This is called your lower limit, this is called as upper limit. So this becomes your L. Then you need a I into N by 4, which you have already calculated, which is 22 minus CF. Now CF is nothing but your LCF, both means the same. Now if I take CF as 30 for that particular column, or sorry, for that particular row, 22 minus 30 will give you a negative. So always your CF will be the preceding value of your quartile row. Okay, so 12 will be considered as a CF. Frequency again will be this from your quartile row. H is nothing but the width between these two. So your H will become 4. The difference between your class intervals. So let's substitute back. L is 64 plus N5 is 22 minus CF is 12. Your frequency is 18 and the difference is 4. After calculating this, you need to write down the answer which you get, and the answer is 66.22 rupees. Okay, since they have mentioned as the units, you are supposed to mention the same units while writing your answer. So the value of Q1 here is 66.22 rupees. Let's calculate your Q3 value now. So while calculating your Q3, again the formula remains the same. You just need to change your I value. So since we are calculating for the third quartile, I will become 3 into your N is already 88 upon 4. So 22 into 3 is 66 observation. Okay. Now we need to search again the 66 where? In your LCF column. Okay. So let's search the 66. It lies between 60 and 72, but we need to take the highest. So this column will become your Q3 column, and the other values will be substituted from here. So your lower limit again will become your 76. Your CF will become 60. Frequency will become 12, and the difference is again 4. So 76 plus 66 minus 60 upon 12 into 4. So which is again 676, 6 by 12 into 4, and your answer is 78 rupees. Since units are mentioned. So we have got the value for Q1 and Q3. Let's substitute back in the formula of coefficient of quartile deviation and get the right answer. 78 minus 66.22 divided by 78 plus 66.22. The value is 11.22 by 144.22. The final answer is 0.0816. So this is the value of coefficient of quartile deviation for this particular question. So see, you have to be very careful with the data given to you, whether it is raw, discrete or continuous, and accordingly you can apply the formula. Now let us look at the last question of this quartile deviation. The sum of lower and upper quartiles is this, and their difference is this. Find quartile deviation and its relative measure. So first let's put down whatever they have given us in the question. This sum of lower and upper quartile is 207.2. So Q3 plus Q1 is equal to 207.2, and their difference, which is Q3 minus Q1, is 39.8. Now we need to find out QD first. So QD is equal to Q3 minus Q1 by 2. Let's substitute that. 39.8 by 2, and the answer is 19.9 for this. Next, we have to find out the relative measure, which is nothing but coefficient of quartile deviation, Q3 minus Q1 by Q3 plus Q1. Total is 207. The difference is 39.8 divided by 207.2.192. So this is the answer for this particular question. Now, in case if you have any doubts or any other question related to quartile deviation, you can comment it out and ask me, and I'll get back to you through your comments. Thank you for watching this